To keep us moving along and through there, so standardisation of aviation charging and the need for robust cable management. So moving us into this little topic there is Joshua Portlock, who's the CEO of Electro.Aero. Josh is founder and CEO of Electro.Aero, as well as founding partner of Electro Ventures and various aviation portfolio companies such as Fly On E and Vertisim. He has over 2 decades of expertise in developing and commercialising electric propulsion and autonomous systems. As an entrepreneur and robotics engineer, Josh specialises in electric propulsion technologies and is a leader in multidisciplinary design, optimised aerodynamics, control systems and sustainable innovations. If you'll please help me welcome for his next session, Josh Portlock, CEO of Electro.Aero.
So I'm sharing more the air side of aviation and the aircraft charging. I've had to use different nomenclature in this audience because I'm usually presenting at electric aircraft with batteries on board, but I have to separate the fact that these are battery-powered electric aircraft that we're focusing on charging, airside. And we can obviously collaborate with EGSC charging as well, but we've been really trying to solve the problem of how you can quickly charge eVTOL and electric fixed-wing aircraft that are battery-powered and even hybrid so they can get back in the air again. So the main lesson we've learned over the last decade of doing this with various companies is don't try and just use car chargers. Car chargers are not going to be suitable for aviation. The nature of automotive charging has been very sporadic and opportunistic, and most people are charging cars at home and at work, and they use public charging networks occasionally on the road, and there's always an abundance of them that you can, oh, this one didn't work, just pull over to the next one. So the quality of service, has been quite lackluster. If anyone's had an EV over the last decade, you show up and every second charge is not working and they've been vandalized or other issues like that. And they just haven't really been optimized for high uptime. And it's credit to BP Pulse and others that have worked hard on that to improve it. But the nature of public car charging has been optimized for a price, not for performance. So aviation is quite different. Electric aircraft have large wings, so it's not as easy to pull up next to a stationary cabinet charger and expect to be able to just plug and play. And aprons are vast. VTOL FATOs, fixed takeoff and landing areas, are large, so you don't want to have to get the $5 million aircraft to the charger, you want to get the affordable charger to the aircraft. The other aspect is that they're so weight optimized, they rarely have enough onboard cooling, and we're often providing offboard cooling, just like you've seen in a lot of the talks about offboard air conditioning. We often are doing offboard cooling of the batteries, either air cooling or liquid cooling, and that makes it a whole much more complicated ground infrastructure requirement than just the plug. And the last point I'll make is the redundancy of the batteries. So you're almost always going to have at least 2, 4, 6, 8 batteries on an aircraft, and that means you often have at least 2 inlets as well. So you've got multi-inlets, multi-batteries, parallel connections, a lot more considerations than just one big string of batteries in a car. So we've been charging electric aircraft commercially since 2016, and I started the company in 2014 because when I started doing electric aviation development, I was doing propulsion and everything you could think of, working with Bell, NASA, Boeing on a bunch of projects, a lot of confidential ones. And the common theme was, oh, charging's a problem, And then in 2017, we started operating the world's first 2-seat electric aircraft, and that became an even bigger problem where we had to drive a diesel generator to the airport that we wanted to fly to. And the irony was the diesel generator kept tripping out because it was a 20 kVA generator and we were trying to charge 20 kilowatts, so we had to throttle it down. So this is embarrassing. It's taking us twice as long to run off diesel than if we just had a plug in the wall. So we certainly learned the need for electric aviation charging infrastructure to make these aircraft viable. So we started doing containerized batteries as well to supplement the grid because there often isn't enough power on the grid, as we've all realized. We also do onboard charge control units. So these are little credit card size electronics that communicate with the redundant batteries. So sorry I'm going fast through this, but for our OEM customers, the airframers, this is really valuable to them because if you buy an off-the-shelf car charging control unit, it's about the size of a shoebox. They usually just tuck it in the back quarter panel of the car and it doesn't matter. It weighs a lot and it'll only do one standard and it'll only do one battery string. So we've super miniaturized that, optionally housed or unhoused, and that's been our moat in the aviation industry to sell those charge control units and distribute them in the wings or wherever they need to be managing the battery charging. And then on the portable charger side, we have our 80 kilowatt flagship product, which we've been shipping for years. We've just launched our 250 kilowatt charger, so that's been very exciting. We lost one of the best slides, unfortunately, of all the aircraft we're selling to. I don't know why we lost that, sorry, but this visually would have shown you all the different aircraft. I might see if we can still try and get that up.
Is it cloudy?
Yeah, I know, right? Yeah, it's really cloudy, you can't see the aircraft. So, I mean, I can sort of touch on the different aircraft. There's everything from one-seaters that are high speed to get medical emergency people on site, like Jump.Aero. There's the five-seaters that are well-funded, the billion-dollar SPACs, as I call them. So they've raised billions of dollars to do one pilot. Yeah, if we can replace it. Don't know what happened there. Yeah, that's the slide. Okay. Yeah. Perfect. All right, going back to the cool, sexy slide. So, Jump.Aero is a one-person medical emergency responder aircraft. So we've been supporting them for over 6 years in their propulsion development, based in California, and we're also representing them in Australia and Asia Pacific. So the nice thing about this aircraft, you climb in from the back, and you're literally in a Superman pose because you've got throttle here, joystick here, and you fly forward face first, looking down at the ground through a nice big window. So, and who doesn't want to be a paramedic that flies in and saves lives, right? So I think the Venn diagram of pilots willing to become paramedics to fly this and paramedics willing to become pilots is like a huge overlap. So yeah, we've got a lot of interest in that. Flies at 400 k's an hour, beats the ambulance by at least 2 to 5 times faster than typically response times. And then Skyfly is a great example of what I'd call a fixed wing becoming a VTOL. So a lot of people have focused on VTOL first, like drones, and then adding wings slowly, like AeroV on the top right there. But by starting as a fixed wing aircraft that can take off and land from a runway, and then it happens to have enough power that you can pull up and land on the spot, is I think a better approach to it, because then you can treat the training regime is like fixed wing pilots with 0 stall speed. So think of it that way, is you don't have to worry about going too slow and falling out of the sky. AeroV still have its advantages as well. They're focused on more of a small wing to augment a multi-rotor. So they've got the benefit of efficient hovering, takeoff and landing, but then when they go fast enough, there's a little wing assisting the forward flight speed. Then you've got conventional fixed wing aircraft like Aerospace. They've got over 1,100 reservations for their aircraft around the world, mostly at training schools, because it's really to modernize training, to replace these Cessnas and Diamonds and others with electric aircraft that are designed from the ground up to get multi-hour endurance and replace the little 2-seaters, 1-hour endurance aircraft that we've been flying for the last 7-8 years. And then vertical aerospace is one of many, about 5 or so, that have still survived the SPAC war of billion-dollar funded air taxis. They're a great customer of ours and a partner. They're based in the UK, but US listing, and they're 1 plus up to 6 seats in their latest design. So it's really the idea of having cabin seating in the back, like a luxury helicopter would, and anywhere from 4 adults and a bunch of luggage, or 6 adults if it's just a mobility-only solution. Ampere have a 9-seat Caravan they've converted to hybrid. Before that, they did a 337, which is it's called a Sky Master. If you're familiar, it's a tandem engine. The benefit of that is they could just replace one of them with electric and keep a certified engine on the aircraft. So that parallel hybrid allowed them to start doing commercial flight operations for the last 5-6 years using our chargers. And now the Caravan is a 9-passenger hybrid aircraft option for long range. And the first 100 nautical miles is electric, and the next 1,000 is petrol. So the benefit of that is any sub 100 nautical mile flights, you're getting like 75% fuel and cost savings by doing it electrically. But then when you need to extend the range, you've got the hybrid to keep going. Anyway, not to get too bogged down, I'm trying to give a 20-minute presentation in 10 minutes here. So our sister company, Vertisim, we've acquired this company to model these vertiport locations, where we're basically modernizing airports, heliports, and showing what the visual layout will be of. And we can actually fly in simulation these eVTOLs in and out of these airports. So that's a pretty exciting opportunity. We're collaborating with a bunch of airports and vertiports on it. 250 kilowatt charger is really the solution to both multiple fixed-wing aircraft charging and VTOL charging. And we feel this containerized batteries, so 12-footer is what we've optimized to. You can fit 3 of them in a 40-foot container. So it's sort of the size of a large genset. You can trailer it, you can truck it, and just place it on site and then start charging. And you can trickle charge it from whatever low source you got. As little as a 10 amp single phase outlet, as long as you're just continuously charging it, you can still fast charge 1 aircraft a day with that. So that's the idea. So standards. It's a bit of a mess, but it's getting better. I've been working on the standards. I started the SAE committee for aircraft charging standard 8 years ago now, and we pushed for the SAE 6968 standard, which is based on the GBT coupler you may be familiar with from China, because it is the most DC power dense coupler on the market, and it's very mature. There's over 1.2 million of these DC chargers in the world, thanks to China and India and neighbouring countries. And that's an order of magnitude more than any other charging standard in the world. The megawatt charging standard is showing promise for the sort of 19-seat mini liners, but even with the mini liners, say you've got 4 batteries, 4 of our quarter megawatt chargers is already fast enough. You're still getting a megawatt out of 4, 250 kilowatt chargers. So actually distributed multiple inlets for multiple batteries is almost a better short-term way to go. I think it's when you get to the 30 plus seats that you now start needing multiple megawatt couplers, but that's just my opinion. Joby have open sourced their standard. It's a liquid-cooled dual DC charging standard, so this is a lot to take in, but if you look at the top little plugs, that's the fluid going in, cooling the battery and coming back out, and then the 2 DC pins means they can charge 2 redundant batteries per wing, and there's 2 of these couplers per aircraft. So it's quite complicated, but that's what they've gone with to get a super weight optimized aircraft, and we're helping them standardize that so other airframers can use it as well. So that's the rough spread. Now I'm going to disappoint a lot of the CCS 1 and 2 people in the audience, but we don't recommend it for aviation charging. Now that's not to say that there can't be an overlap or bridging of using CCS 1 and 2. Like, I think it's a great standard for cars, of course, and any GSE that are in the high voltage, it makes sense for now, but longer term we want to see standardization towards 6968 or the Joby GX coupler, or a combination of the 2, because you don't really need the AC pins. All these aircraft are so weight optimized, they can't justify a big AC to DC converter on board the aircraft like you can tuck in the back of a car. And car charging most of the time is AC charging, so it makes sense to have the onboard equipment. But most of the time aircraft charging is DC charging because it's about turnaround time. So the AC charger is just, no airframers we've talked to can justify the weight of having it on board, so you don't need the pins either, the top half of the CCS 1 and 2. We also provide 28 volts auxiliary power for the low voltage battery charging as well, and that allows you to undersize the auxiliary battery, undersize the DC-to-DC converter, and again, more weight optimize the aircraft. So there's a few other things I could touch on, but that's our push, and we've been pushing it for 8 years. There's about 70% market adoption of 6968 amongst airframers, about 20% adoption of CCS 1 and 2, and about 10% proprietary like Joby and whatnot. So we're doing the 250 kilowatt as our flagship launch this year. We've already got dozens of orders I'm trying to keep up with. And the 80's been shipping for a while. I've got over 1,500 now reservations for the 80 kilowatt chargers, so it's more of a when they're going to need them problem than if they're going to need them. We see the 80 kilowatt being sort of in every hangar for aircraft to charge, whether it's fixed wing or VTOL, and the 250 being on every FATO. That's our mission. We're ISO 9001 certified, we're 1401 environmental certified, we've got all the DHO certifications that cost me a fortune, but it's been worth it. And we've really worked closely with the airframers to make sure we're aligned with their needs. So the future is even more powerful, as you've seen. So we've developed a 640 kilowatt DC charger. The challenge is it's near impossible to put 640 kilowatts worth of AC to DC converting on board a mobile platform. So this is where we start moving to DC coupled. You're probably familiar with the difference, but AC coupled is where you've got AC coming in, the cable guidance system, and DC out. DC coupled means we've got cabinets of chargers on the back end, like you've seen a Tesla supercharger with their exotic little cable holder, but really they've got a cabinet of camouflage AC to DC converters somewhere hidden away in the bush. So that is more of an infrastructure challenge. You've got to work with the airframe, with the airports to place that AC to DC cabinet somewhere and run all the DC wires. But that does allow us to deliver 640 kilowatts over 2 320 kilowatt hour plugs for these really ambitious eVTOLs. To be honest, no one's there yet. Most are happy at 250 kilowatts, but some have sort of said the roadmap is going that way. The other aspect is by not having the AC to DC charging on board the cabinet, the mobile cabinet, we can fit liquid cooling as well. So this one's an onboard liquid cooling for both the cables and for the batteries, where the 250 we provide a supplementary liquid cooling or offboard cooling system. So you can, with 6968, SAE 6968 can deliver up to 640 kilowatts per plug, which is really industry leading. Tesla and others have been doing this in China for a long time. It's not rocket science for them because it just has bigger pins. So you can do 650 amps up to 1,000 volts, whereas CCS 1 and 2 are limited around that 320, 350 kilowatt, maybe briefly 500 kilowatts, but it throttles down very quickly when the pins get too hot. And yeah, just emphasising that you often want to get inlets into the wings. So bringing the charger around the back of the aircraft and running the cables up to each wings means you've got unobstructed access to get people in and out of the aircraft, which is really what you're doing this for, is to get people in and out. So you don't want them tripping over charge cables and having issues like that. So I'm conscious of time, but I'll whiz through this, emphasising the modularity is really important. So you could start with an 80 kilowatt, upgrade to a 250, start with a short cable guided system, upgrade to a long one. We're really flexible in that, and we make sure everything's plug and play. So it's all based on standard IEC 60309 outlets, and in the US we offer California 50 plugs as well. If you're not familiar, it's a 50 amp twist plug that's relatively affordable and readily available, and that way you can just plug and play and make as many AC extension cords as you want. And this is what I mentioned about power bays. So if you start going beyond a megawatt, in fact even about half a megawatt, you start needing to plan your DC infrastructure, AC to DC infrastructure, and you start needing to have like containerized batteries and in this case the AC to DC cabinets. And making sure you've got some bit of real estate, usually ground side, not air side. So usually off air side, and then running the DC cables into the air side is the more better use of land space. So in summary, we've got a commitment to lead the electric aviation charging industry. We are about 70% market share at the moment, so we're really happy about that. We just want to maintain at least 50, and work with anyone we can to continue making sure electric aviation charging is easy to roll out, literally, pun intended, roll out physically, plug in, and start charging these aircraft. So that's not the bottleneck of us being able to fly around electrically. So thanks for your time. I'll leave you with this video looping through questions. And it shows you our most recent 250 kilowatt charger with our 22 meter cable guidance system and 8 meter plugs. So you basically got 30 meters of reach from where it stores out of the FATO area out to where you plug into the aircraft, so 100 foot in the American language. And that's what people have asked for, up to 100 foot, like 50 to 100 foot. And they can choose how long the cable guidance system is. And it's plug and play. So it's 425 amp outlets. So you don't have to plug and play that too often. That's like, occasionally move the charger. But once you have plugged it in, you can just roll it out. And obviously the DC plug is the one that's plugged in every single flight. So thanks for your time.